Good morning, class. I will be explaining to you what the equinox is. So here we have the sun, and here we have the rotation of the earth. So right here we have, these will represent the seasons, and here we have the vernal equinox. Ver comes from the Latin word meaning spring, and autumnal comes from the Latin word meaning autumn. So equinox, if you break that down, equus means equal and nox means night. So this means 2 times out of the year, we'll go with March 20th, which is the beginning of spring, and September 23rd, the beginning of autumn. And this means that 2 times out of the year, the sun crosses the equator and day and night are everywhere on the earth of equal length.
Okay, good morning, class. So today I'm going to be talking about solstice. So before we get started, I'm going to break this down. So sol means sun, stis means stop or stationary. And now I'm going to explain how this incorporates into the equinox and solstice. So I'm going to be talking about the winter. Winter actually starts December 21st or 22nd. Here is where the earth is. So the sun actually focuses on giving daylight here. And then for summer-wise, once again, this is the earth. The sun focuses on giving the sunlight here during summer, which is June 21st or 22nd. Okay, and I'll be referencing it within the timeline. As you can see, December, June, and December again, which ties back down into the seasons. Now I'll be explaining as far as like a pyramid. Winter, it's at its lowest point, and that's its shortest days. And then as far as summer, it's the highest point, and it's the longest day within the year. Now, when I mean the target points, it's because when you look at the sky, you can see if it's at the highest point or at the lowest point. So this is just a breakdown as if you were looking at the sky. So once again, summer is at its highest point, and then the winter is at its lowest point.
So how do holidays connect with seasons? So I'm going to talk about Christmas, one of the holidays that everyone really enjoys and loves. So back in the day, instead of celebrating Christmas, they would celebrate the winter solstice. During this time, they would appreciate the ends of the short days and the days lengthening to more sun and longer days. So during this time, after 6 months of the sun rotating south, it stays at the lowest point, as mentioned. During this time, it stays 3 days, December 22nd, 23rd, and 24th. And on the 25th, it starts rising up. So does this sound kind of familiar, the 3 days and rising up, something religious? During the resurrection, the Son of God rised up. So this is why we celebrate December 25th as the birth of Jesus. And let's go further along with Easter, when we celebrate resurrection. During Easter, they calculate the first Sunday after the Paschal's full moon, which occurs during the vernal equinox. The full moon lands on Sunday, and then on the next Sunday after that would be Easter. During this time, the sun starts hitting the earth more, and during this time, the light overpowers the darkness, which connects to why we celebrate the resurrection during Easter.
Okay, class. So speaking of days, we're going to transition into 2 other topics. But first, I'll break down this diagram for you guys to get a better understanding. So first here we have Earth. And as you know, Earth rotates on its own personal axis, which means that it's rotating, just constantly rotating like this. Along with that, the Earth also has its own orbit that goes around the sun. So it's rotating like this, but still following the orbit around the sun. Along with that, we also have fixed stars that are put into perspective. And I'll explain more of that later on. So we have first solar time along with sidereal time. I'll go ahead and break down solar time for you guys. So solar time is measured from the rotation of Earth around the sun and from the sun's perspective.
So the clocks that we use are based on solar time. And keep in mind that from the perspective of Earth, we see it as not us rotating around the sun, but instead the sun rotating around us. And so this means that the clocks that we go by measure the length of time required for the Earth to rotate around the sun, giving the perspective that the sun revolves around the Earth every 24 hours, which is the days that we go by. And ultimately, this creates what is known to be a solar day. So moving on to sidereal time. Sidereal time is measured from the motion of fixed stars in the sky because of the Earth's rotation. So to break this down in more simple terms, fixed stars are a term that's used from the Earth's perspective in terms of when we're on Earth, we see stars as always being in the same place, in the same location every day, which that's not necessarily the case. So the Earth is rotating on its own axis while it is still orbiting around the sun. Throughout the day, the Earth moves an estimated of 1 degree along its orbit. So that's why, from our perspective, the sun moves about 1 degree from the east to the west, which relates to when we wake up in the morning, we see the sun on one side, and then when we go to sleep at night, it goes to the other side. So what all of this ultimately means, class, is that based on our clocks that we go by, which is solar time, this means that stars will set and rise 4 minutes earlier each day. Okay. So, Jimmy, what did you learn?
Neutron.
So, I learned a lot. So, if I was to time travel, I would need to calculate sidereal time, not our man-made solar time. This is important because the differences in Earth's rotation can determine whether I land in the same location or somewhere in the middle of the ocean. Every millisecond counts in astronomical time.